Hello everyone, in this series of videos I will be teaching you guys the basic components in an electrical circuit. So this is a typical circuit which has the three most basic components that you will see, that is the resistor, an inductor and a capacitor. So now I will be teaching you about a resistance and in detail. So resistance, what is resistance? It is defined as it is the property of a material by which it opposes the flow of current through it. So it is denoted, you generally see it as this way. And do note that if you start drawing it from this part like it is elevating, so you have to end it like this way. And SI unit for the SI unit for resistance is ohm, which is denoted as this sign while writing, and it is denoted by the alphabet R. So what happens is resistance, it stops, it not exactly stops, it opposes the flow of current passing through it. So the resistance of a material depends upon the physical properties of that material, and it is given by a standard formula, that is R equal to rho L by A. So R is the resistance. We have three unknown variables like rho, L and A, where rho is resistivity in ohm meters, L is the length of that material, length in meters, and A is the cross-sectional area in square meters. So this is the basic part. Now we will see that when current is passing through a resistance, it absorbs some power. So power absorbed by a resistance. Power absorbed by a resistance is actually time dependent, so it is denoted as P of T, and it is given by V into I. So by Ohm's law, as you may know, by Ohm's law we have V is equal to I into R. So now for I will be writing it as V by R. Substituting this value of I in this equation, I get, so this will turn out to be V square by R. Again, using Ohm's law, V, as I know that V is equal to I into R, I will substitute this part now here. So I will be getting IR square by R, which will turn out to be R square by R. So these both get cancelled. Therefore, the final equation for power absorbed by a resistor is equal to I square into R, where I is the current, R is the resistance. Next, if anytime the resistances are connected in series, you will have to know the equivalent resistance. So now we will be studying resistances in series and in parallel. So resistance in series. So this is a typical circuit. This is a typical circuit where there are three resistances connected in series. Let this be R1, R2 and R3 connected to a DC source. So suppose if current I is flowing from here, so I, do note that in this case the current flowing through all the resistances will be equal. But if we just consider like a few notes here, voltage across these three resistances is different. Let us denote them as V1, V2 and V3, and this is the equivalent voltage, supply voltage V. So here, as we know that the current flowing is same and the voltages are different, but these three voltages are equivalent to the supply voltage. Therefore, we can write it as V equivalent is equal to V1 plus V2 plus V3. Now again, from Ohm's law, I have V1 equal to IR1, V2 equal to IR2, and similarly V3 is equal to IR3. Because current passing is same, I'm not going to change this sign, but it is for different resistances. So now I will be substituting these here, which will be IR1 plus IR2 plus IR3, taking I common. So now if I write a general equation for this one, which will be I into R equivalent. So now R equivalent in a circuit when it is in series will be R1 plus R2 plus R3 up till Rn. This means that in a series, in a circuit where resistances are connected in series, we can just calculate the equivalent resistance by just adding them all. Next, now we will be seeing resistances in parallel. Resistances in parallel. This is a typical circuit showing three resistances connected in parallel. So yeah, these are connected in parallel to a DC source. Suppose current I is going from here. In this case, let this be R2 and R3. In this case, the current is actually, this branch is splitting over here. So the current will also split. I1 as I1, I2 and I3. But it is interesting to note that here the voltage across all three resistors will be the same, which is indeed equal to the supply voltage. So these two voltages are now same, and here current is being splitted. So I can write it as I is equal to I1 plus I2 and I3. And again, by Ohm's law, I have I1 is equal to V by R1. Similarly, I2 is V by R2, because V is a constant here, like V is not changing. And I3 is V by R3. Substituting all these three values here, I get V by R1 plus V by R2 plus V by R3. So now taking V common, 1 by R1 plus 1 by R2 plus 1 by R3. So now when I compare it with like a general equation, which will be I equal to V by R equivalent. R equivalent we take because we have three resistances and we always want the total resistance in that circuit. So if I compare it, this equation with this previous equation, I will be getting 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula we use to calculate the equivalent resistance when resistances are connected in parallel. So suppose if we just have two resistances, we can calculate the equivalent resistance by, so if you just solve the LHS part, we will be getting R equivalent as R1 R2 by R1 plus R2. You can just remember this small formula so that you shouldn't this is like a complicated process doing 1 by R1 and 1 by R2 all the time. When there are two resistances connected, you can directly calculate it by this, using this equation. And one more term that is very closely related to resistance is conductance. We generally don't use it that much, but just for your information, what is conductance? Conductance, it is denoted, conductance is denoted by the sign G, and it is nothing but it is the reciprocal of resistance. So we can write it as G equal to 1 by R. Yeah, so that's it regarding resistance. Thank you for watching. That's it for today. So if you have any doubts regarding this video, please let me know in the comment section below, and I'll be more than happy to clear your doubts. Thank you, and I will see you in the next video.